Right. So then let's discuss more questions.
Yes, sir.
Yes.
Yeah.
So this is also from. So what's the question?
Yes, sir.
CMI tomato. Nice book.
Yes. So I think it stands for the same thing. Test of mathematics at plus 2.
Yeah. Okay. So let's tell me the question.
Oh, so I should give you a question, or are you going to give me a
Oh
question?
no, you will give. I have no questions.
Okay, sir. Let's see, sir.
Okay, if you don't have any questions, then I can try some questions.
Right, top of my head, I don't have any
You don't
questions
have.
right now, sir.
Okay.
So,
So then maybe So let me then give you a question. So let's talk about this. So number of tilings.
tilings.
Yeah,
Okay.
let's number of tilings, because I was just thinking about this 5 minutes before the class.
Okay, yes, sir.
So let's see. Number of tilings of a rectangular board. Yeah.
Number of tilings of a rectangular board.
Of a rectangular board. So let us see. So let's see. So there is yeah. So let's say that we have a m by n board. Okay.
Integer sided, sir.
Yes. Integer side. I mean m rows and n columns. Okay.
Okay, sir.
So and so for example, this is a 5 by 5 board. So this is
Yeah.
the
Yes, sir.
exactly the example that I didn't want. I want some even.
Yeah, not a square, or
No,
maybe
it could be a
uneven.
square, but I want even number of sides.
Okay, so
Even
6 by
number of
5.
cells. Yeah, this one becomes a. Okay, so I will say 5 by 6. I want to say the rows first. Okay, but
Okay.
and then you have these. You have dominoes. Okay, tiling.
Yes.
Tile with dominoes. Okay, so you understand what that means.
Huh. Yes, sir. Dominoes, like those small rectangles.
Yes, like 1 by 2 rectangles.
2 by,
You can 2 by
yes, sir.
1, 1
1
by 2. You can use them
by
vertically
2.
also, obviously, and you want to tile them.
Yes, sir.
So then, so let's say that Tm comma n is the number of ways.
Tm command. Okay, sir.
So Tm comma n is the number of ways. Okay. Now here is another question. Here is another counting problem, and I will want you to show some connection between them.
Yes.
Not count any one of them, but show a connection. So
Correct. Okay, sir.
yeah. So now. Yeah. So now you have, let's say, mn points. Okay. So they're just randomly drawn like this. So there are mn points. So there's 1, 2, 3, dot till mn.
Okay.
There are
Yes, sir.
mn points, and yeah, and this is like there are these edges. Okay.
Okay. Yes, sir.
Exactly like we have here, right? So now we're basically looking at it as a
Yes.
graph, looking at it as a graph.
Okay.
Okay. and so on, right? You understand?
Yes.
So the scheme of the edges is clear. First, so now I want you to count the number of ways to match the mn vertices. Okay? I'll define what that means. Number of ways
Okay. Yes.
to match the mn vertices. What do I mean by match? I mean pair up the mn vertices. Okay,
Okay.
such that you can pair up two vertices only if there is an edge in between them. Otherwise, you cannot pair them up.
Okay.
Okay, so that's like a
Yes, sir.
matching. We want to create a matching. Okay, number of ways to
Okay.
match the mn vertices. Okay, and let's say that this is pm comma n. Okay,
Okay.
so the two questions are clear. The two problems are clear. I want
Clear.
you to
Clear.
show that tmn is equal to pmn.
Okay.
Yeah, it's not difficult. It just the whole jargon is there. Otherwise, it's probably not difficult.
Let's see. So and in the MN in the domino styling question, we're
Mhm.
assuming that the domino is 1 by 2 or 2 by 1.
Yes, so domino means like that. Otherwise, it's tromino or something. But anyways, yeah, it's 1 by 2, 2 by 1. Yeah.
Okay. 1 by 2, 2 by 1. Okay, sir.
Yes. Yeah. And by the way, here m and n need not be even. I mean, it's any integers. Okay. Any
Okay. Yes, sir.
integers. Yeah. Here I have given an even example because probably there it's. Okay. Think
Uh,
about think about this. So maybe I'll just make an interruption. Here I'm just saying
yes.
that just to maybe this matching thing is a little new that you're hearing. So just to suppose we have this, right? So we have 1, 2, 3, 4, right? So
Yes.
what would be
Sir.
a matching? Maybe I will say I will pair up 1 and 2 and 3 and 4. This is a matching,
3,
right?
1 and 4 also.
Yes, right. So we can also do 1 and 4 and 2 and 3. This is also a matching. Now
Yes, sir.
4 and 1 and 2 and 3 is not a different matching. That's the same matching.
Same matching. So the order doesn't matter.
Order between, yeah, that's right. The order doesn't matter. These are a matching. Are there any more matchings?
In this
No,
case, no, sir.
no.
One. Yeah. In this
In
case,
this
no.
case, no. So there are two matchings. And so that's what I just wanted to make clear. Now you can
Okay.
try to,
Two matching.
yeah. And also you can check that there are, okay.
So, sir, what I'm thinking is, suppose we uh, we
Oh,
first we take uh 2 by n column, 2 by n section of the board, right? So I was
hmm,
thinking something like that,
okay.
and maybe
True.
do something with that. But what I'm getting confused is, here these edges that we're counting, it has that
Uh-huh.
middle edge also. So I'm not seeing where the dominoes will like exactly come in.
Yes,
So
yes, yeah.
maybe
Oh,
what I would
no.
do is,
So this is,
I
yeah,
would
this, sorry. So this, so you notice that the problem is incorrect? Like for the
yes,
small,
yes,
even for the small example, right? It's not correct. I mean, the number of
yes,
tilings
sir.
is one, and is not there. There are no tilings, and then there are matchings. Yeah,
No tilings.
yeah. So
Correct. Yes, sir.
yeah. So this is incorrect question. Um, the edges I have to tell you in a different way. Edges are incorrect.
Okay. Yes.
So the edges are like this. No. So how should the edges be? 1 second.
Yes.
So I think I don't know. So what I was thinking is to make a graph like this.
Yes, sir.
So I'll
And
tell
this
you.
graph one we can ease count.
No,
Okay, like
no,
that.
the
Okay.
counting. I'm not asking you to count the number. That is not easy. Okay, but
Yes.
I'm saying that the way I was making the graph is like this. For every cell, I am making a vertex. Okay,
In the
and
middle.
then yes, right, and then I'm joining them like this.
Okay, yes.
Okay, and this is precisely the graph that we get that side. Okay, so maybe we're just making the question on spot, and yeah, like
Okay,
this.
so
Yeah, so this is the graph. Now you see if you
count the number of lines and see the tilings. So, sir, we can take a small section. So, suppose we take that square section, upper left.
section
Number
meaning
of ways to tile that are four.
which one? This one?
That 2 by 2, that section. Yeah, 2 by 2.
Mm-hmm. Number of ways to tile that are four.
So if you're given 2 by 1,
Oh, so the question is
4,
correct, right? Yeah.
and
Yes, yes, yeah.
question is correct if we view it like this. Yes, sir. Yes, sir. Yes,
Yes,
sir.
yeah. No, it was correct either ways. It was correct before because see, because when you take these four, so the question was correct because when you take four vertices, then here you will have
Yes, sir.
four cells, not one cell, right? Because yeah,
Correct, correct. Yes,
yeah.
sir.
So the
Got
question
it.
was correct, and now probably you've got a hint at the proof also.
Yeah. So now we can say that TMN is equal to PMN. But
Mhm.
sir, before we conclude that, just to be more confident, can we consider a rectangle 3 by
No,
3?
why is
Say
it
3
true?
by.
No, why is TMN same as PMN?
Well, that's just my hypothesis right now, sir.
Yeah,
But
but
if
that's
I
what I
had
asked
to,
you to prove. Okay,
okay, let's
that's
see,
the
sir.
question.
So,
That's the question here. Yeah.
uh, okay, yes, sir. So this vertical line, one vertical line corresponds to joining two, as in tiling two spaces vertically.
By
So
like a vertical domino.
yeah, by one vertical domino,
All right.
and similarly, one horizontal line corresponds fully to joining two horizontal cells by a 2 by 1 domino, like that.
Yes.
So if we count all the lines, then of course we're counting all the possible configurations. Is my thinking?
Yes. Yes. And that is correct. That is it. Now if we just write it. Yeah. That is correct.
Yeah, now we just write it.
Yeah.
Yes,
So the problem is easy, but yeah, it's interesting. No, the
we
reason
needed
why.
a shift of perspective. Yes,
Yes, right. Because we already drew it here. But you see one interesting thing that just even this graph, initially it was not even clear that you
yes,
can pair up all the vertices. Like it was not
correct. Yes,
completely off. So maybe it was, but right, it's interesting. And also when one of them is zero, then both are zero, right? Because number of tilings is
correct,
zero if and only if both are odd. And in that case, Mn is odd, and then you can certainly not pair up the vertices.
correct, correct. Yes, sir.
So this is a
So
interesting. Mhm.
maybe what if we this is maybe it won't work, but what if we set up a bijection? Can we do something with that?
Yeah,
Now we have proven it, but
you have
suppose
already
that idea didn't come
no.
to my mind.
So
Can we
see,
set up a bijection and somehow show that this graph and then this rectangular board, they're equivalent or something?
no. So that's what you have done, right? More or less, right? So basically, setting up a bijection is what you have to do when you write it formally, right? Right? Is that's what you have to do. So you will say something like this, maybe. So consider a particular tiling, right, of the board. Then for every rectangular domino that is between cell number aij to aij plus 1, that corresponds to joining those vertices in. Sorry, I got disconnected. Yeah. Yes.
Yes.
So the setting up the bijection, just try to think about it and try to write it. Okay.
Okay.
Yeah,
Yes, sir.
because
I'll think about.
what you have said is you have already set up the bijection actually. Okay.
Yeah, but like I wanted a formal, like
Yes, yes.
something
So
like
you
that.
try to, yes, exactly. So you try to write it. Okay. It will
Okay.
not be
Yes.
difficult. Yeah. All right.
Yes, sir.
So this was just a problem that was connected to something I was reading. So
Okay. Yes, sir.
now there is one more question that comes in this topic of tiling. Okay. So now let us say maybe I'll call it possibility of tiling. Yeah.
Okay. Yes.
Possibility.
Possibility.
So let us say that now what you are allowed to use is, let's say, a 1 by 4 or 1 by 4
Okay.
domino.
1/4.
You can obviously also use it vertically. Okay.
Yes.
So now um, uh, the question is, can we use 1/4? I mean, that's already clear. So I'll just say, can we tile, and can
Yes.
we tile um, let us say 10 by 10 board?
10/10. Okay.
I don't know the answer to this. I think something, but let us see.
Yeah. Even I have a feeling, but again, it's
Hmm.
not confirmed.
Yeah.
So I think we begin by there are so now, so there are two options we can do. We can do the graph one, or we can draw the rectangle one.
Uh, yes,
But
but
for
see
the
the graph one, it will not, now it will not correspond to matchings because now it's a 1/4.
so correct, correct, yeah.
So it has to be
But
something
maybe
else in the graph.
we can modify the graph. I was thinking so.
Ah, okay. All right. So how do you do?
So
Or let us take a 6 by 6, right? And
6/6. Okay.
so that, so yeah, so you're saying draw a different graph, maybe.
Perhaps with a space of 4 between or something like that.
Hmm.
Yes, sir.
So numerically it is matching because 36 is also a multiple of 4.
Yeah, yeah. Numerically, like that, we can. That is fine. That
That there's
yes,
no obstruction there. But
yes.
the thing is that, look, 4 does not divide 6. But is
Correct.
that,
Yeah, that was. Yeah.
yeah, yeah, is that
Otherwise, it would have been a bit trivial. It's almost.
yes, otherwise it would have been trivial, right? So yeah.
So, so we've gone from a trivial question to a somewhat hard question, like extremely hard question.
No, I don't know if it's extremely hard. But yeah.
So if we were to draw the graphs
Hmm.
again, let's see what would happen if again we did the same thing. We put the nodes of the graph in the middle, the points.
Ah, okay.
Let's just see what will happen. But now two lines, sorry, four lines will correspond to one horizontal tiling.
Yes. Yeah.
Four lines will correspond to one horizontal tiling. Same way, four vertical lines will correspond to one vertical tiling.
Right. So it's, yes. So it's like grouping the graph into blocks of 4
Yeah, or
vertices.
instead of that, we can just delete some of the vertices. We make the distance more. We make the distance a bit more so that instead of
Yeah, but if you
saying that
delete
four,
vertices, if you delete vertices, because you see a
Oh,
tiling,
right.
yeah, like you can shift
Right, right,
it
right. We
and
can't do that.
maybe,
Some
yeah,
squares will be left.
yeah, maybe you can do it, but it doesn't seem to, yeah, seems to be complex.
No, I think we can stick to this only. This
Hmm.
4 vertices. I mean 4 edges.
Mhm. Like, see,
We
if
will
you have
get
1 by 4 and 2 by 2 cell, a 2 by 2 board, it's not possible.
correct. Yeah,
Yeah.
clearly.
Yeah. So this is also probably not possible. If you try a little bit, right? So sort of see that it
Huh.
fails. Yeah. So we should try to prove it is not possible. That is,
Yeah.
yeah.
I was thinking we should try to prove that it is not possible.
Yes.
Uh, so sir, let's first consider just the top row. If
Mm-hmm.
suppose there was some tiling, then it would be fully tiled.
Mm-hmm. Yes. Yes.
If the so let's see the possible ways in which that can happen.
Uh-huh.
We can have one domino in the first 4 cells, like totally 1 by 4,
Okay.
and then we can put 2 vertical dominoes next to that.
Mm-hmm.
Now, just in this case, we should try to figure out, a contradiction or show that this case
Yes.
is not possible. So,
Mhm.
or that it is possible, maybe.
Yeah. It's probably. Uh, yeah, I think in this case we can sort of prove like, okay, if, but you have to take a few more like branching of this case. Like maybe you say, okay, if I
Yeah,
put this, um, yeah, it still branches. Mm,
yeah, it branches. It
a
branches, yes.
little bit, yeah.
But this configuration, I think it's in this configuration, just a few cases we can show that it doesn't work.
Yes, yeah, that's correct.
Uh, so maybe I think case by case only we go, sir.
Huh, but no, case by case, but I mean, I understand. Like you, when you once you take this case, then in a way you see this is like the only case
Yeah,
by
yes, sir.
rotational symmetry.
Ha, by rotation. Yeah, yeah. 6 by 6, it's a square, so it has 4 symmetries.
Yeah, so okay, that's a, yeah. I mean, the point is that one of the sides you will have to put a horizontal, right?
Correct.
And
Oh,
then this case, so basically this is the only case, and you it's fine. I mean, so 6 by 6 you can do, but you see, we want to do like for 18 by 18 also, it is not possible.
or M by N.
Yes, where m and n are even but not multiples of 4.
Yeah.
That's what we would like to
4K
be able
plus
to.
2.
Yes, that's right. So how do we do it? Okay, so here is a
Uh,
idea. uh,
yes, sir.
so this is again a trick that I know. So
Okay.
and so, and I don't know if it works, but in, let me delete this. I don't know. Tilings is a very mysterious thing somehow, right? I also fail to
Yes, so
understand.
I read this. This is just rectangular tiling. I've read about hexagonal, pentagonal, all those tilings, and
Yes.
something. I think pentagonal tiling in 3D or something is not possible. It was proven or something. I'm not quite sure, but very
Uh-huh. Yes,
interesting.
yes, yeah. In the theory of tiling, there are a lot of open
Yeah,
questions. I also try to
open
listen
question.
to some seminars. I don't know. I also don't understand much because I'm not. I don't work. I have not studied much about tilings. Okay. Uh,
Yes,
yeah.
sir.
But yeah. So there is this technique, and maybe by telling you, I can understand this better.
Yes, sir.
They say that, okay, you see what I'm doing.
One,
Just
three, four.
just
Ha.
number them.
Just like ha. Okay.
Hmm?
Yeah, but with the constraint that they're between 1 and 4 because 1 into 4.
Yes, and just keep writing 1 2 3 4 1 2 3 4. Just in the so that it looks good. Okay.
Correct.
Like even vertically it's 1, 2, 3, 4, and horizontally also it's 1, 2, 3, 4.
Yes.
Cyclically.
Yes, sir.
Right. So so this is like a way to, it's like putting extra structure on the board, right? And
Somehow,
somehow,
yeah.
yeah, and the possibility of tiling would somehow contradict that structure.
Correct. Yeah.
And this structure
I
is
can,
very
like,
nice because, yes, this structure is nice because it sort of globalizes the information also, in the sense, right, that the sum of the numbers on the board and so on is something.
perhaps, yes, sir. The sum, we might be able to do something with the sum. Yes, sir.
Yeah, and it will contradict that. So now you see, yeah, should I leave it as a homework for you to try from here?
Homework.
Yeah, I mean, just
So
give it a try.
I'll give it a try, sir.
Yeah,
I'll
because
give it a
I
try.
don't want to spoil it, because I already know. So if I keep saying, then it's no good, right? Yeah,
Yes, sir. Yes, sir.
just think
So
about it.
6 by 6, 6 by 6 board, 1 by 4, or 4 by 1 domino tiling.
Yes, yeah,
Is it
or
possible or
maybe
not?
yes, or maybe I'll say like this. Like for this one, maybe I'll say what you are already thinking. It's like you see, like every time you put a 1 by 4 cell, whether you put it vertically or horizontally, it will use
Yeah.
exactly 1, 1, 1, 2, 1, 3, and 1, 4.
Correct. Yeah. Correct.
So it will use equal number of them,
Huh.
but we don't have equal number of 1s, 2s, 3s, and 4s.
On the board.
Yes,
Yeah.
and you can, because it is clear.
Correct. So
Yeah.
so now I'll have to generalize this. Like,
Yes,
or
yeah. Yes, you have to generalize it, and that will be the challenge for you. Okay.
okay.
Also,
Yes, sir.
maybe if you want to take the challenge further, then you can do this.
Yes.
Now you are supposed to tile using m by n rectangles. Using m by n rectangles.
Huh.
Use m by n rectangles to tile m by n board.
Okay.
When is it possible?
M by N. Okay.
Yes.
Capital N and capital
Yeah,
M
capital
is.
N, capital N,
Huh.
and this is one. So this is the
When is it
further.
possible?
Yes. Like
Okay.
obviously, if m divides m and n divides n, then it is possible, right? Easily.
Correct.
But
Huh.
in other
Or if
cases,
the parity is different, it's not possible. So you already ruled out many.
yes. Yeah. You can think about this. And the answer will be
Okay.
exactly the same, in the same flavor. Okay. So yeah, this.
Yes.
Yeah.
So
So
when will our next class be, sir?
uh yes. So we can meet next Sunday, just
Sunday.
7
Okay.
7 a.m. Yeah. And I was
Huh. Okay,
thinking,
sir.
like, I did tell your mom about 2 hour class, but I was thinking that two
Yes, sir.
hour will probably be a bit too long for me. Okay.
Huh.
Like
Yes, sir. Yes, sir.
yeah, like so let us keep 90 minutes and see. Okay. I mean, the
Okay.
other logistics I will adjust with your mom, but okay.
Okay. Yes, sir.
Yeah, we can keep this, and I think this should be long enough, right? Because we
Yeah.
want to
Yeah.
keep it,
Perfect. Thanks.
yeah, intense enough. All right.
Yes,
So
sir.
think about, and maybe I'll share with you this the last 1 minute, just this thing. This is where I was reading. I mean, I was here for a certain different reason, but
Yes, sir.
I'll just show you. This is a very interesting topic of domino tiling.
Okay.
Okay.
Counting tilings.
Yes, and in this Wikipedia page, I was reading for some reason, but then you see the first thing came about number of perfect matchings. So
Okay.
which I just made a question out of that, and I asked you. So that was a small thing. And then there are some
Yes.
interesting things like height functions. I don't know if you read about it, it will be interesting.
Interesting. Yes, sir.
Yeah, but now counting the number, this formula
Huh.
is quite daunting.
Cos. I don't know where cos is.
Yeah, I also don't know. So if sometime in the future, maybe obviously not, maybe not before the entrance exam, okay, after the entrance exam, if you are interested, then please I ask me. If you can find a reference, otherwise I'll give you some elementary reference, and then you can read and present it to me, not as a class, but just
Yes,
as
sir.
a discussion. Okay. I want
So, and
to.
one more interesting thing is,
Mhm.
uh, this I just read this here. Special case occurs when 2 by n it reduces to the Fibonacci sequence, which is
Yes, I was didn't
again.
want to. Yeah, this is so that was supposed to be a problem, but now you have seen it.
Oh,
Yes, yes. No, no, no.
okay,
I mean, no, no. I mean, that's there's no. I'm just joking. Yeah, this also you can try to prove. This is actually Fibonacci. And
okay,
actually, this is what I was discussing with a kid, some class 7
okay.
student, and somehow it got into this. Okay, that was some. Yeah, so you can. Yeah, if you are interested, then after the exam, I will maybe see you. I don't expect you to be able to find the right reference to read it. Okay, because some of the proofs will be very advanced. Okay, but there'll be some elementary proofs
Yes, sir.
also, hopefully, and then you can try to present it. This is what I do with my people whom I discuss with. I ask them to read something or just so that I'll also learn, and then when you present, yeah, it will be a good discussion. Okay? But okay, that's for
Yes, sir.
later. Yeah. Okay, then I will see you next week. Okay.
Yeah. So one last question about
Yes.
this challenge. Am I
Uh,
allowed to discuss it with my friends, or perhaps is it independent?
no, no, you can do anything. Yeah, you can discuss it
Okay.
with your friend. That's up to you. Yeah, do what you
Yes,
want.
sir.
Yeah,
Okay, sir.
yeah. All right.
Yes, I'll try it, and I'll give you my findings by next class,
Yes,
next Sunday.
yes, yes, yeah, yeah. Okay,
Okay, sir. Thank you,
okay.
sir.
Take care. Bye.
Yes.
So now, yes. Hi, Aparna and Ishana. You just maybe just give me 2 minutes, okay? And also this meeting, yeah. Yes, I'll just come in a minute, okay? Just get ready with the questions, okay? We want to discuss this application of trigonometry. We laid the basic theorems last time. Today we want to do some questions. And yeah, so just get ready with the questions. I just come washroom. Yes, I'm ready. let us. Yeah, and sorry, let me do one thing. I just maybe launch the meeting again, right? Because there is no point. Yeah. So you people have questions, right? So just tell me the question after we meet. Okay, I just end it and just join again. Sorry for the inconvenience.